Good afternoon, everybody, and welcome to the third SWAN Asia Pacific Alliance webinar. The focus of this webinar is advancing water loss management in Southeast Asia. We have three great presenters lined up for you today who will share their experiences of implementing smart water solutions to address this global challenge. I am Mark Nicol, and I'm the leader of the communications group of the SWAN APAC Alliance. I'm also the International Sales Director for Jalur Water Products, where I'm responsible for the Ecologics and Singer brands outside North America. Our three presenters today are experts in their field. We have Mr. Abe from Maynilad Water Services in the Philippines. We have Khairul Effendi, the CEO of Ranhill Water Services in Malaysia, and Ahmad Samhan Daud, who's the head of the NRW division of Jalur Cahaya Sdn Bhd in Malaysia. This webinar is being hosted by SWAN, the Smart Water Networks Forum, a global non-profit which is the leading global hub for the smart water sector. This slide shows some of the different global SWAN members. We now have over 170 members with more than 50 utilities as part of the Alliance. These global water utilities, large companies, startups, engineering and consulting firms, academics and investors all come together to help grow and generate the smart water industry. The goal of the SWAN Asia Pacific Alliance is to accelerate smart water and wastewater development in the Asia Pacific region through the SWAN Forum's collective expertise and industry partnerships. The Alliance offers access to specialized webinars, workshops, and a central source for smart water research. This webinar is free to attend. However, future webinars and events will only be available for free for SWAN members. So please do look to sign up if you're not already a member. As you can see from this list, we have several innovative alliance partners already collaborating within the Asia Pacific region. And if you're not a lead partner already, we hope that you will come and join us soon. The Asia Pacific Alliance has been established just over 1 year ago, and we've had a very active 14, 15 months since then. We've had several successful events, including 2 utility-led webinars. We held a Smart Water Forum at Singapore International Water Week in 2018. And recently in Noosa, there was a workshop, Noosa, Australia, there was a workshop which was co-hosted by Unity Water. So before we start with the presentations, I'm going to give a quick overview on the situation that we're looking to address. Water, like many of the world's precious resources, is threatened by misuse, overuse, and pollution. The statistics you can see on your screen show just how big a problem we face globally. However, I always believe a picture paints a better impression than some numbers. It's hard to put into your head what this volume is. While the volume of leakage is the same approximately as the flow over the Victoria Falls in this picture. This is a huge volume of water that I'm sure we all agree we should and need to address. This is particularly a problem in Asia Pacific, where many countries are in a water crisis. Growing populations, rapid urbanization, increasing water pollution, and competing demands for water have left water resources in many Asian countries in a critical state. The gap between supply and demand is widening, and there is increased competition between water users, such as farmers, households, businesses, etc. Utilities in Asia also have every reason to worry about water loss. They can lose up to 65% of their production daily, with most utilities in the region averaging at least 30% losses. However, there are great examples across the region where water loss has been reduced to or below economic levels. Singapore, which is where I am based, is renowned globally as one of the leaders with very low losses. Another great example is Phnom Penh Water Supply Authority in Cambodia, who reduced their non-revenue water from 72% in 1993 to just 6% in 2007. I think we'll all agree that's a remarkable feat, not just in Asia, but globally. Now, the key to developing a successful strategy to manage non-revenue water is to understand the reasons for its existence and the factors that contribute to its rise. The techniques, solutions, and approaches can then be customized to address these specific needs. Today, we're going to hear from 3 specialists for water loss management on how they've leveraged smart water solutions to help bring down water loss in the regions they work. We will have a Q&A session at the end of all 3 presentations. Please do ask questions during the presentations by typing your question into the chat, which you can see on the right side of your box. We'll also be holding polls throughout the presentation, so please do keep an eye out for these and answer as needed. The first presentation is due to be Abe from Maynilad. Okay, please begin, Abe, when you're ready.
Okay. So I will be sharing with you our experience in managing the NRW and the process in Maynilad's EDMA Automation. And as we go along the presentation, I hope that you could identify the technologies and the equipment that can help a typical water company. Maynilad is the largest private water utility in the Philippines. It also provides water and sewerage services in the west zone of Metro Manila. We cover about 17 cities and municipalities. We also serve about 9.3 million customers and having 1.3 million connections. We also have 6,500 kilometers of mains in our system. Our production capacity is about 2,650 million liters per day. The situation in the West Zone during 2007 is that we have a high NRW, which is 66%, which is about 1,500 MLD. And 75% of our NRW was physical losses. This is due to leaking and aging pipes. We also have a poor service level, and 50% of our customers has good water supply. We also have a poor, we have also 81% service coverage, and 3 million people has no access to pipe water. And because of this reason, in 2007, the management decided to focus on the NRW Reduction program and to come up with a strategy to reduce NRW. So the NRW strategy that we use is first break up the network into manageable area, diagnose these areas, address their NRW, and manage NRW. We use the district metered area approach to efficiently manage our NRW. With the district metered area approach, we have created 1,600 DMAs, and was a challenge for us to manage and monitor these DMAs manually. The first thing that we did in manually monitoring these DMAs is manual reading the meters for each of our DMA. In cases if the vaults are flooded, we dewater the chambers. We also have a bad traffic condition that makes reading the meters really hard. So in some cases in Maynilad, we cannot dewater the chamber. We use an improvised telescope to read the dials of each of the DMA meters. So the limitation in manually monitoring each DMA is that we have insufficient data for our analysis. Data are read once every month, which is insufficient in our analysis. And because of this, reaction time takes longer, and in cases we have breakages in the network. Too much manpower is also used just to gather the data, and sometimes endangering the safety and welfare of our teams. So to solve these limitations, Maynilad implemented the DMA automation. So basically, DMA automation is the process that enables our metering point to send data automatically from the site to Maynilad servers. So the figure shows that the flow of data from the field to our computers. We basically install data loggers on our meter entry points and critical points. The loggers are then send the data through our telco and transmit the data to our data logger server. The data is then viewed by our area engineers for their analysis of any anomaly on the DMA. Now we can see the complete flow and pressure profile for each of the DMAs for our analysis. We also have a 24-hour leak profile and do minimum night flow analysis. We can also now see more data and trends to analyze. The figure shows the early data logging setup of Maynilad. So we have a typical data logger installed in the meter and the connections to the pipe or pressure points. So you can see the antenna also on the vault itself. Another part of the DMA automation is to change our old process in data collection from other corporate data. The previous setup is using Excel spreadsheet to consolidate all the corporate data. The result of this spreadsheet will help us in the NRW program and activities that we do in each of our DMAs. But since it is mostly manual monitoring, it is limited and reactive, making it inefficient. What we did is to have a system that will automatically collect the data from our corporate data and calculate all the needed reports to efficiently select the NRW programs and activities to be planned. Currently, these are all of the corporate data in Maynilad. So we have our telemetry data, which all of the monitored flows, pressures, and TAC levels are stored. Second is the customer data, where all of the billing, customer consumption, and customer details are located. We have also our GIS data, where all of the asset from which have spatial data concerning the infrastructure assets and the non-infrastructure assets are located. So lastly, we have also our customer complaints and jobs, where all of the maintenance and leak repairs are installed. So these four corporate data has their own database and management system, and we want the NRW management system to help us relate this data with each other. This NRW management system will help us in the decision making on what NRW program and activities to be implemented. It's just a one-stop shop that will show you all you want for NRW reduction. So the next slide, I will show you the example of our NRW management system. First, we have the information system. For this slide, it shows you the hierarchy of all of the area in Maynilad. So we do it from the largest area to the smallest one. So for this example, you could see that we have the business area until the lowest part, which is the meter reading units. Another part of the NRW management system is the map. So it shows you the map of the boundaries, pipelines, PRVs, meters, valves, hydrant, and our customers. Another example of our NRW management software application is that you could see the customer, which is the red one, and you could see the customer information. So all of the details for the meters, serial meters, and the date installed, you can see it here. Next, you could see the consumption trends. So this is the monthly consumption trends of the particular customer. We use this, we use it normally to check if there are anomalies on the customer. For example, we have particularly customers which has illegal activities. The system has also a logger and telemetry information system, or we call it lattice. It shows the flow pattern from each of the inlet meter and the pressure port on the monitoring. So you can now analyze the flow at the meter entry point together with the pressure from the meter end critical point. For us NRW engineers, the most important is the night line or the minimum night flow, which shows you typically what is the physical loss on the DMA. In addition, you can also see the effect of pressure management if you have a dual set PRV for this example on the slide. This is a breakage that is seen in lattice. It shows you the drastic increase of supply for the area, which indicates a mainline burst due to the abrupt increase in flow. You can also identify the start of the breakage and the repair. It will also show you the time when we did energize the system and shows you the trend after the repair to validate if the supply and pressure returns to normal. The NRW Management System also has its own water balance. So it breaks down the NRW for the real loss and the apparent loss. So for the real losses are the leakages, and apparent losses are illegal connection or measurement errors or billing errors. The result of water balance prompts the NRW engineer whether to look for leaks or to investigate for illegal activities. This is another example of the NRW Management System where it shows you a typical NRW monitoring report. So monthly, it can generate DMA NRW. This slide shows you the KPI summary for the DMA. This one, you can see a chart for each of the DMA. This one is the most interesting part of the NRW management system. Because we have so much DMAs to monitor, we set alarms for each of the DMA. So by setting an alarm, we can generate envelopes or threshold using the historical data in setting the alarms. For this one, you can see the green line as the flow, and the red one is the upper and lower threshold that we have created. So once the green line passes or crosses these red envelopes, it creates an alarm. This is the sample alarm dashboard. So it shows you the DMAs with alarms. This example of alarm has volume above and shows you the data flow on the left corner and the location of the meter on the map. So with the NRW management system in place, the basic process in our day-to-day operations using this system is first, our NRW engineer opens the system. So the system shows the DMAs with alarms. Second, NRW engineer checks customers' complaints or maintenance activities on the area. If none, NRW engineer will dispatch the team to investigate. Next, we do the leak detection and repair of the leak. And lastly, we do the evaluate if all of the flow and pressure returns to normal. So in conclusion, DMA automation is an effective tool in managing NRW. It also provides real-time data and is available when needed. It also alerts the engineer immediately when problem in the network arises. All of the data resources are also used and sometimes shows us another ways to improve other systems. And lastly, provides information to better manage and prioritize NRW programs. That is how Maynilad manage NRW. And from our experience, it is clear that NRW management is really a data-hungry activity. And since we are working in a dynamic system that changes constantly from our sustainant DMAs and diagnostic DMAs, we need an automated means to gather, process, and analyze the data. And with the help of the advancement of technology and new solutions, we could help in other water utilities in reducing NRW. That's all. Thank you.
Thank you, Mark Miko. I'm Khairul Effendi Tusam from Ranhill Water Services. Today I'm going to talk about the data-driven NRW Management System, a case study that we have done in the state of Johor in Malaysia. So the state of Johor is in the peninsula of Malaysia, located south of the peninsula neighboring Singapore. Johor has the second largest water supply system in Malaysia, after Selangor, albeit being the fifth largest state in Malaysia. The water supply system covers some 19,000 square kilometer area with 3.8 million population. The water operator in Johor, Ranhill SAJ, manages the supply through 44 water treatment plants and 22,000 kilometers of pipelines, serving 1.15 million customer accounts. The supply coverage is about 99%, with all the customers metered and billed every month. The total production for Johor is about 1,800 million liters per day, and the current NRW level stands at 23.7%. And then in the state, NRW is measured every month. At the moment, Johor has 1,088 district metering areas, or DMAs, with 95% coverage. So that means the whole state has been zoned out and monitored. Ranhill SAJ has started to implement a holistic NRW reduction program since the year 2000. And over the years, numerous sensors and monitoring devices have been installed to capture as much data as possible from the water supply system. These thousands of loggers and sensors from the different components of the water supply system, i.e. production, storage tanks, distribution, customers, etc., they transmit millions of data to the office every month, making it too overwhelming to manage. And then it is worsened by the different brands of equipment used, which means there are many different softwares and interfaces to deal with. So all these issues result in lengthy analysis duration, human errors in analytics because we depend on manpower to do the analysis, and delay in result translation causing slow response. And then there are these various types of equipment on the field, resulting in many different softwares, and laborious and staff intensive in terms of the data analytics. And then the slow NRW level reduction due to delayed corrective actions, and we had limited accessibility to NRW data information for quick response, and then also it hinders effective strategies to be implemented going forward. So therefore, going forward, a tool for quick decision making is essential to refine NRW reduction efforts. For ease of monitoring, all field-related data is compiled into one system. This allows a one-stop system where data from all different loggers and sensors are integrated into a single platform. And being web-based, the system can be accessed from anywhere in the world as long as you have the password and internet connection. This feature gives the top management access to the current status without having to rely on potentially bogus info from their personnel. We started with only 3 modules back in the year 2010. At that time, we only had DMA monitoring, reservoir monitoring, and job management system. but by now we already have some 12 modules in the system. And then, of course, going forward, more modules will be introduced, including the capability to calculate NRW level from the system itself. The modules that we have now include DMA monitoring, advanced pressure monitoring and control monitoring, reservoir monitoring, online pressure monitoring, production van and reservoir outlet meter, peak customer meter, NRW stock tracking, stock management system, smart DMA, government RMS, commercial loss monitoring system, and AVLS. Some of the terms I'm going to describe further is, for example, the job management system. NRW job management system actually deals with the repair works. That means as soon as we find the leaks, we have to report it to the contractors, and the contractors will get them repaired. So all the processes are monitored and managed through this job management system, and it goes paperless. Everything is done online. The smart DMA is actually the installation of permanent loggers on the DMAs to enable automated leak detection. And then AVLS is the automatic vehicle locating system to monitor the movements of all our vehicles on the field throughout the state. In order to be holistic and effective in our NRW reduction effort, the 4 pillars of physical and commercial losses are adopted, and the functions of AquaSmart cover all these components as well. In the physical losses component, which is shown here, 7 modules are used. So we have the job management system for the speed of repairs, we have the APMC and online pressure monitoring for the pressure management, and we have again job management system and also DMA monitoring for the pipe rehabilitation. And then for the active leakage control, we have the reservoir monitoring, remote monitoring system, smart DMA, and then DMA monitoring. For commercial losses component, we have the commercial losses monitoring system and big customer meter monitoring to manage all the meter errors, meter under registration, water theft, and accounting errors that contribute to commercial losses in NRW. So this is the snapshot of map view in the DMA module. So the system gives us an almost real-time data whereby every morning it will show us the status of the DMA night line on that same day, earlier that morning. For example, if you come into the office, the data will start to come in at about 7 a.m. and then it will be completed by 9 a.m. So it will show us the data, the status of the DMAs, what happened between 12 and 4 a.m. that same morning. And then every pin here represents the actual geocoded location of the DMA meters. So we can see that the DMA distribution is more dense on the south, where Johor Bahru is. And Johor Bahru is the capital of the state, and it's a bit scarce on the east coast. The different colors represent the different status of the night line for each DMA. Generally green being good and red not good. So on the right, we can see the distribution of the DMAs according to their status in terms of numbers. For example, from here, we had 1,082 DMAs registered in AquaSmart, and we have the different numbers for the different status of the DMAs based on the colors. And then our active leakage control teams are also provided with mobile tablets, so they can check the status of the DMAs and act accordingly every day. So we have about 70 teams here to manage the whole state of Johor, and every team will have their own baby DMAs for them to take care of. Each team will handle between 15 to 20 DMAs. So every morning they will just turn on their tablets and they know where to go. They will look for the orange and the red ones. Those are the potentially problematic DMAs. And we have teams stationed in every district in Johor for quick responses. This is the Smart DMA, one of the modules in AquaSmart. Smart DMA is where noise loggers are permanently placed on site to continuously detect leaks. In our case, we don't actually put it down permanently per se. We call it semi-permanent because we move it around after 3 to 4 months, simply because there's a lot of grounds to cover and loggers are not cheap. So we have about 700 loggers now, and so far for the past 1 year we have managed to do about 20 DMAs on this approach, and then we have managed to save about 7 MLD from this exercise alone. So in this system, all the loggers, the noise correlators on site, will show us the location of the leak in the system. We can just look at it from the office, so we can be aware of it immediately together with the location of the leaks. So we really have to go down to the site and verify the leak using a ground mic and get it repaired. So this process eliminates leak locating, step tests, etc., and then the hassle of finding and pinpointing the location of the leaks. This is a tabular record that we can see in the DMA module. So from here, we can actually zoom in to any DMAs that we want to see, and we can see the trend or the track record of these DMAs since the date of its inception. So if the DMA was established in the year 2010, we have all the data since 2010. This is to enable easy analytics and also trending for every DMA. It can be viewed in the form of a graph as well. We have two types of graph, the MNF graph and the normal graph. In this case, the MNF graph, it shows us the minimum night flow, the total flow, and also the baseline for every DMA. The baseline is where is the one that we set when we first established the DMA. So we want to see how much reduction that we have done since the DMA was established. So the baseline is equally important to measure our performance. This is taken from the job management system. This is on the site job registration and report. So all leaks that are found by our ALC teams will be registered in the system from their mobile tablet, complete with a picture. So once we take a picture of the location, it will come together with the coordinate. And then this registration will go straight to the contractor as well, because the contractor will receive the job from the system as well. All the contractors are required to have their own mobile tablets. So once they receive the job sheet from the system, they will just open it up, and using the coordinate that comes together with the picture, they can straight away identify the location quickly and get it done. And once it is done, the job will be verified by our site supervisor and approved in the system as well for payment purposes. So everything is done in the system online. This eliminates the need for any paperwork that can actually delay the process. This is how we monitor the job repairs. So in the state of Johor, there's a lot of leaks being repaired every day. So we repair about 200 leaks in the whole state without fail every day. It totals to about 6,000 leaks a month. So the management of the repair works is very important. That's why it is all monitored in the system. So from here we can see that once the planner put down the job, it will go green until it is completed. And then once the job is handed over to the contractor, it will go red until it is completed before it turns green again. So any ID will not be closed until the job is approved by our site supervisors. That means there will be no pending jobs. The charter that we have for all the leak repairs is within 36 hours. So all jobs reported in the system must be completed within 36 hours. It has to go green again within 36 hours. Otherwise, the subcontractors will be penalized. So this is another useful graph or charts that we can see from the system. We can actually monitor the performance of every ALC team in the system. We can see the DMAs that they are responsible on, the status of every DMA. And then we can see from the chart how many of the DMAs are red, how many are green, and how many are blue, and so on. So we can see the performance of every team from this chart alone, and also the performance of all the DMAs in the district. The advantage of the systems, one important thing for us to fine-tune or refine the NRW reduction is by reducing the ALR, awareness, location and repair. So it is very important for us to reduce the awareness time and then the time we take to locate the leak and the time we take to get the leaks repaired. So by having this system, we have managed to reduce the time taken for all these complete processes from an average of 66 days to only 5.5 days. This has further greatly assisted in the refinement of NRW reduction in the state. So this is what it has done. It has contributed to the NRW reduction in the state of Johor. We have started doing NRW reduction since the year 2000, and from this graph we can see that initially it was about 36%, and then until 2005 we started to do things in piecemeal. We still had a lot to learn at the time, but NRW was like going up. And since 2005, we started to implement a more holistic approach in NRW reduction. So we started to see some reduction before we go to a period of stagnancy, between 2007 and 2009. That was where we realized that whatever activities that we did at that time was enough to overcome the NRR, the natural rate of rise. And then we had to introduce more teams to manage the DMAs. And then in the year 2010, we realized that a lot of data started to come in, and we couldn't continue analyzing the data manually using all the manpower that we got. So we started to introduce this data management system, and then since then it has assisted to further fine-tune the NRW reduction in Johor until where we are now at 23.7%. So the conclusion that we can derive from this case study is that as NRW level gets lower, all processes have to be refined in order to squeeze further reduction, because there will be no more low-hanging fruits at this point. So the best way forward is to carry out a big-scale pipe replacement program if we have the resources to invest on that. Otherwise, we have to adopt this alternative way of NRW reduction through the refinement of all the processes. So using the awareness, location and repair concept, the ALR, all these three components have to be done in the quickest manner to minimize losses. And then after having all the infrastructure in place, data collected from various sources have to be analyzed and interpreted in a single platform to enable quick corrective actions and planning. And then in this case, data speaks to utility operators, so we don't work in the dark. So thank you, everyone.
I'd now like to pass over to Samhan from Jalur Cahaya, who is going to share with us, discuss about advanced technologies for water loss in Malaysia, and I believe he's going to talk about large diameter transmission pipes. So Samhan, over to you.
Thank you, Mark. I'm Ahmad Samhan bin Daud, Head of NRW Division in Jalur Cahaya Sdn Bhd. I started as NRW engineer in year 2000 and about 18 years working in this industry, specialized in large diameter pipe leak detection and pressure management, including advanced pressure management. I would like to share my experience about 3 case studies and result of using the technologies in reducing physical loss in Malaysia. I started with the presentation with the NRW statistic in Malaysia. Overall statistic of NRW in Malaysia, it shows that NRW extremely high on the average of 35.3%, which the highest state recorded at 63.1% of NRW. It showed that not much activities on the physical loss reduction or apparent loss reduction to lower the NRW on the most of the water utilities in Malaysia. So our topic today, we are talking more on water loss. Water loss can be divided into 2. The first one is apparent loss, and then second one is physical laws. I will talking more on physical laws, which the main topic that I will present the case studies today is about leakage on transmission mains pipe and leakage on service connection up to the point of customer metering. That can and also on the advanced pressure management. For leakage on transmission mains, the behavior of transmission main, dominator transmission mains, the pipe was started from outlet of water treatment plant to reservoir, and normally it's a very large diameter of pipes. Like example, in Malaysia, it started from 300 mm and up to 2,200 mm size of pipes, and depth of the pipes under the ground can be more than 2 meters, and some places is up to 3 meters. And also pipe alignment are unknown and make difficulty for leakage inspector, even for visual inspection, to locate the leaks. And then due to the high pressure of the pipes, any pipe leaks will create high volume of losses. And if pipe break event happen, it will create to thousands of people. Like recently it happened last 2 months after in Malaysia we have Eid celebration period. It affected more than 800,000 of customers, and we do not want this event happen again. For the case study number 1, I will talk about pressure surge on the trunk main pipes. One of the main causes of leak on large diameter pipe is pipe surge, and it normally happens when immediate closing at inlet reservoir, inlet up to the reservoir. This behavior cannot be traced by normal 15 minutes data logging, and we need to use high frequency data logging in order to detect this event. Like in this example, for 800 mm pipes, data on the data logger is show only 66 meters, but actually on the when we're using high frequency data logging, it can be up to 109 meters, almost doubles of the what can be traced by the normal data loggers. The surge happened when the immediate closing at the reservoir inlet, then the pressure oscillated from 5 to 109 meters, and this event happened. This millisecond change from 5 to 109 meters and back to 5 meters can create pipe burst somewhere at the weak point in the system. And today I would like to talk about the technology that we use to locate the leaks on large diameter pipes, which is one of the technology we call free swimming non-tethered technology. This technology is able to locate a very small size of leak or pinhole size of leak up to 1 liter per minute with the accuracy of 1 to 2 meters and the capability to do a long inspection by single deployment, as what we did an example in Borneo and also able to locate trapped gas, and this technology suitable for any type of pipe material. And the limitation of this technology, the minimum pipe, it only suitable for the pipe size 300 mn and above, and with the flow, with the minimum velocity at 0.3 meter per second. So I would like to highlight the result of the first case study, the second case study. We are using a free swimming non-tethered technology for the 850 mm supply area. This graph actually from the water treatment plant, and we clearly see that before and after we repair the leaks. We found about 88 numbers of leaks on this survey. We are survey about 140 kilometers of pipes, and from the leak repair of 88 numbers of leaks, we managed to reduce the production from 54.4 mld to 49.3 mld, with the saving is about 5 mld. The second case study is about where the successful of the first case study case study at 850 mm pipes. We moved to large diameter leak detection service project. This inspection we started on February 2013 and until May 2016 is about 3 years, with a total pipe inspect 1,893 kilometers, range from diameter of 300 mm to 2,200 mm. We managed to found 645 number of leaks, or 1 leak for every 2.9 kilometers. And estimate total saving from the leak repair, we managed we managed to get a total saving of 45 mld. And then we move to pressure management. We know about the benefits of pressure management. Pressure management is the fastest and economic solution compared to other methods. Pressure management can reduce burst frequency and also energy savings, and can improve the customer service, extend the asset lifetime, and also for reduce the overall operational cost. This table is about the comparison between leak size compared to pressure. On the first table, you can see that at the pressure of 60 meters, if the leak diameter 8 mm, the size of leak is 101 meter cube per day. But if you reduce the pressure to 30 meters at the same size of leak, at 8 diameter, we can see that the volume reduced from 101.1 meter cube to 69.1 meter cube per day. So I'm talking about the advanced pressure management. There are 2 types of pressure control. The first one is a fixed PIV control, but by fixed PIV control, it control only the downstream of the PRV. But during the night time, the critical point pressure will be fluctuated and increased during the minimum night flow. But the second one is advanced pressure management, where we fix the critical point and then let the inlet of the system adjusted according to demand. and also by reducing pressure at night, also it will give more saving to the system. Case study number 3 is about, I want to share about large area pressure management. This profile is one of the area of the installation that we install the controller at the PRV. We can see that it started the minimum net flow from 45.5 liter per second and reduced to 22 liter per second with a saving of 1.1 mld from the implementation of the advanced pressure management. You can see that the green line started with fluctuated from 20 to 40 meters. By the end of the but when the critical point is clearly at the after 1 month, we can see that critical point is stable at around 80 meters, and the minimum net flow reduced from 45 to 22 meters. And it gives a very good result on the saving reduction of physical loss. And this is a 3 area that we installed advanced pressure management on a large system. We can see in the table, it started from 8 mld, the first one for KP001 to 7.2 mld. Also for KLM002 started from 6.8 mld and reduced to 5.7 mld, and KLM003 started from 7.9 mld and reduced to 6.4 mld. And overall saving from these 3 installations, we managed to reduce 3.9 mld, or average of 1.1 mld per installation. And conclusion from my three case studies today. The first one, the trunk-mainly detection give a good result on physical loss reduction, but still less focus from the water operators. Number 2, pressure surge is one of the major contributors to pipe leak and burst. Number 3, large-scale pressure management project proven give good impact to physical loss reduction. And number 4, water operator must give a priority for pressure management and advanced pressure management program, because it gives a significant impact to physical loss reduction. Thank you.
We've had several questions coming throughout all 3 presentations, which is great. So thank you everybody for asking those questions. We have about 5 minutes left of this webinar, so I want to try and get through as many of the questions as we can. However, if we cannot answer the questions you've asked, please note we will answer them for you. This session is being recorded, and we will ensure the answers are provided in the recording, and also that that we feedback to you on your specific questions. So the first question, I'm going to simply ask these in the order they came in, is to Khairul, who presented first. Khairul, the question is, do you know how much Johor have spent to reduce NRW levels so far? And is there any calculations done on the return on that investment? Has it shown to be a positive, worthwhile investment? I guess this is for those people who are starting that journey. How much are they going to need to spend?
Yeah, thank you, Mark. To answer that question, it is very difficult for us to calculate the amount spent for NRW reduction alone, because like I said earlier, to have the NRW reduced, we have to do it in a holistic manner. It covers every approach of our operation, from HR, finance, even admin, the way we manage our vehicles for the teams and everything, the trainings that we have carry out for all the people, not only the NRW people, also people in the network department, production, customer service, whatnot. So it is virtually impossible for us to come up with a reduction for how much we have spent to reduce NRW. The only thing that we can come up with is the amount that we have outsourced. So the amount that we have outsourced comes out to about maybe 50 to 60 million ringgit a year for the reduction, but that is only part of the processes. And then there are also things that we do in-house, which we cannot really quantify. For example, if we send out our people, our meter readers, so they can read the meters properly with good integrity and all that. So we cannot really justify how much spent for them to do that. So it is virtually impossible for us to come up with that, except for the outsourced portion, like I mentioned just now.
Okay, thank you very much. And for those that aren't Malaysian, 50 to 60 million ringgit per year is in the vicinity of 10 to 15 million US dollars per year, which is being invested. I think we would all agree that the results show huge savings, and I'm sure that Ranhill and the state of Johor has saved significantly more than has been invested. But as Kyle mentioned, it's very integrated. So that actually leads to another question we've had, and Kyle, I'll ask you to answer this first, and then we can ask the other two speakers. But what do you see as the role of resilience planning for water loss management in Southeast Asia? Does that link in with your strategy for non-revenue water? Hello, Kyle, are you there still?
Yeah.
I don't know if you caught the question, but how do you see resilience planning as part of the water loss strategy to ensure long-term sustainability of supplies, given climate change and everything like that that's going on?
Yeah, it has to be very resilient in that sense. We have to have a very good planning going forward, and we have to know the system well for us to do this. That's why we have learned a lot from the many years that we have spent in the state of Johor since the year 2000, because system changes every now and then, and then we have to actually be able to respond to whatever changes that happen around us, especially nowadays when there's a lot of new development coming in, with a lot of new demand coming in, and going forward, the water resources depleting in terms of quality and quantity. So going forward, we're going to focus the NRW reduction more on the Johor Bahru area, where the buffer is getting lower and lower. And then we are also embarking on a large-scale pipe replacement program. We're going to replace some 7,000 kilometers of pipes in the next 7 to 8 years. By doing that, we hope that we can reduce NRW to below 10%, so that we can be more sustainable going forward. The idea is not to actually extract more water from the resources, even groundwater, because the best way is for us to use whatever that we have in the system already. Don't waste it, and then use it to the best we can.
Okay, great. Thank you very much. I'm going to move over to Samhan. A couple of questions that came for you, Samhan, relating to the technologies that you talked about. We've been asked, can you share what devices you used in terms of both your pressure management and your non-tethered invasive leak detection? And did you use different solutions, or was it one solution that you used in all examples?
For the large diameter pipes, we are using free swimming non-tethered technology, or we call it smart ball. We have a large smart ball project for the 3 years started on 2013, 2016. And also apart from that, actually, I not put in the slide, because not all are covered by, because there is limitation on smart ball, limitation on the flow requirement only can suitable for 0.3 meter per second, and the pipe size above 300 mm. Some area we cannot put smart ball for the survey, so we are using another technology which is called ecologics or eco-shore for the trunk main. So with these two combinations, we can cover most of the pipe main or large diameter pipes in the system. The second one, for the advanced pressure management, we are only using a single product. We call it I2O advanced pressure management, because we see that this technology is give a very good result on the we are talking about the advanced pressure management. Our aim is to get a flat control point pressure. This is the most important thing. We need a technology that can give a very stable and flat pressure at the critical point. So far we are using the I2O advanced pressure management. So that's my answer.
Okay, thank you very much, Samhan. I will ask a question to Abe. We've had several questions, Abe, but the one that I'm going to ask, in fact, I'm going to ask two. One is, what do you see as the role of performance-based contracts for managing non-revenue water? And I asked that to you because I realized that Maynilad has gone through performance-based contracts in the past. And secondly, what is the software, the NRW software that you used that's given you such great successes in identifying where to target your strategies?
Yeah, can you repeat the first question?
Sure. So the first question was, what do you see as the role of performance-based contracts in managing non-revenue water? And the second question was, what's the software that you use that you were sharing with us during your presentation? Hello, Abe, are you there?
Yeah, the advantages of performance-based contract is you could really monitor all of the jobs that you could do or give to the contract. And for the second questions, we use NetBase as the NRW Management System, which connects to all of the corporate data. But the problem is all of the corporate data must be ready upon the connection. And it will also depend on the actual software that this corporate data that you have. So for us, we have different data systems for each of the corporate data. So for example, for telemetry, we have OSISoft for that one. For our billing, that would be SAP. And for our GIS, we are using Manifold. And for WMS, it's Microsoft Dynamics.
Okay, great. Thank you very much, Abe. I'm not going to ask this question because unfortunately we're out of time, but that leads me to a question on integration and the challenges of integrating systems. But let's leave that one for now because we've run over time. We have several more questions, but we will make sure they're all answered for everybody. One of them I will answer immediately, which is, can we have a copy of the presentations? And the answer is yes, this webinar is being recorded and we will share that with everybody once the webinar is finished. So thank you very much, everybody, for joining. Thank you to our three presenters this afternoon for sharing with us. I hope it's given everyone some food for thought on how to address this challenge in the Asia Pacific region. And I hope that many of you will look to join the SWAN Forum and the Asia Pacific Alliance to help us continue to grow and address this challenge in the region. Thank you very much, everybody.
Thank you.
Yeah, thank you.
We've had several questions coming through throughout all three presentations, which is great. So thank you, everybody, for asking those questions.